Right, so we are doing coordinate geometry. Now this is something that you've kind of done over and over and over and over again. So we're just going to go through it very quickly. Alright?
Is this a whole topic? Or?
Well, that's what I'm thinking as well, because it goes all the way through, and these are basic skills that you have to have, but people do forget and struggle. Okay? So basically, when we're talking coordinate geometry, there's certain things that we want to make sure that you're okay with. Right? You might laugh, but just coordinates. Being able to put coordinates down on paper, and stating the coordinates of a point in space, and so on.
The first one's the one that goes across, right?
Yes. Yeah. So on a Cartesian grid,
That's a fancy name.
it is, yeah. Okay. So Cartesian grid is just a fancy name of everything you've already seen. We have our x coordinates, right, goes into negative x, and we have our y coordinates down to the negative y coordinates. In the centre is obviously the 0 coordinate, and when you state the coordinates of a point, so point A, the coordinates would be x followed by y. Yeah. Now, this is one thing maybe is overlooked when we teach this. What does the coordinate mean to you? So just where it's located on the grid. Yeah. Does it have any other meaning to you whatsoever? So, for instance, if I said I've got a set of coordinates that is 3, 5. So I'll call it point P is coordinates 3, 5. What does that mean? Tell me anything you can about that.
A line crosses through that, like that's where a line hits. Like if we were doing a line.
Okay, yeah.
Like,
So a line would go through that point. So I would consider it slightly different in that that point is part of the line. What line though?
The line that's on the Cartesian grid.
And where does that line come from?
A function.
A function, okay, a function. Alright? So, we know that we have x and y. Do you know why it's x and y for coordinates? Because that's what we use when we're using a grid. When we graph things, we have x coordinates and y coordinates. When we go into 3 dimensions, which you will do, the third coordinate will be z or z for me. Okay? But what does the x and y actually mean? Well, it means that if I were to put x into a function of x, I would get an output that I call y. Alright? So, another way of writing that would be f of 3 equals 5. How many functions are there where I can put x in and get 5 out?
3.
Only 3. What are they?
Oh, to right?
No.
Oh wait, no, yeah, I just clicked 3 because it was F to the power. So
Oh, as f, it's not f to the power.
Yeah.
As f of 3 means 3 is the input, 5 is the output. How many functions could I use to make that happen?
2.
Only 2? What are they?
Oh wait, well it depends. No, because you could do like 3 plus 1 plus 1. And then 3
That
plus,
would simplify though, wouldn't it? To just...
so 3 plus 2 and then 3 minus negative 2.
Okay, so what would the functions be? So that would be f of x would have to be, well, I'll start you off with x plus 2.
You could have 5 or minus 5. Right?
Now I want the input to be 3, the output to be 5.
Yeah, so 3 minus negative 2.
Well, give me a function. It's got to have an x involved.
So x
So another function, g of x, could be,
X minus -2. X.
well, that's kind of the same as x plus 2.
X minus -2.
Yeah.
Yeah, that's x plus 2.
So we got 2 plus.
2x. There you go. Now we're starting to
We
think.
already had that.
2x minus 1. h of x, 3x
Minus 2.
minus
9, 4.
4, and so on.
Okay, well, that was a trick question. What's
No.
the answer to that?
Infinite.
Good.
I could have x squared, so I'll just do a different one. I've run out of my letters. X squared, but then it would be
3 to the
minus
4.
4. Another g of x could be,
X3.
well, this would be maybe a bit harder to work out, but it could be log to the base 3 of x. See whether you do this one then. And then what? Plus or minus what? What's x again? 3. So it's log to the base 3 of 3, which is 1. So I need to add 4 again. Yeah?
Oh, 5.
Because we're doing, put 3 in. So all of these functions that I can think of, like I could get even more, like e to the power of x plus minus something. I have to work it out. That would be a hard one, wouldn't it? Because it would be e to the power of 3, and that's going to be a irrational number, and then, you know, so I'd have to adjust it. But that's what the coordinates mean. 3 to 5, that's what it means. That. And where do these lines come from? So all of these functions can be plotted on a set of Cartesian grid. So we have Cartesian coordinates. But where do the lines come from?
The grid.
The what?
The grid.
Oh no, we haven't even considered that yet. What are the lines that you draw? The function. So explain to me what you mean by that. So for instance, if I were to draw one of these functions, let's draw 2x minus 1. So we start at minus 1 and go up like that, yeah? So that's something we've got to consider. Do you know how to do that, yeah? 2x minus 1, you can draw that. Where does that line come from? What does it mean?
When you put it through the function, that's where it ends up.
Y equals that. It's where it crosses the y.
Well, we know that's minus 1. We know that if we do the gradient, you've got rise over run. This is what we've got to remind ourselves about, is 2. Yeah. Are you all good with that? Alright. But where does the line come from?
Oh, when you use that.
This is the thing that's always overlooked, isn't it? You don't really know where the line, you just draw a line, don't
Is
you?
it the like that equation? It was y 1 plus. Oh wait, no, you need line.
Wait, no, it's a bunch of functions. Like the line passes through all those functions.
Well, not functions, but
But it's the line equation.
What?
Think the line of.
well, maybe if I say this, it isn't a line.
It's part of a curve.
Little points.
Yes. How many
I said
points?
the coordinates.
An infinite amount.
An infinite amount of points. So, for instance, the point that we were looking at was 0.35, yeah? So if I know 3, I read up to my line and I go across, I know it's at 5. I know I have a coordinate there, don't I? I have a
Only
point.
1 point of the line passes.
That's 1 point, right? If I'm doing a linear function, the 2x plus 1, what I'm saying is that these are all the points that match that function, where the input and output. So I know that -1 on the input, if I put it through that function, will give me what output? Yeah, see this thing? Easy stuff, but you don't really know, do you? If I put -1 into 2x minus 1, what output do I get?
2 minus 1, that's negative
Oh, sorry, I've
2.
done something wrong there. So it would be
Negative 3.
-3, yeah? How do I get this point here, this -1? What's the input? So my output is -1, what's my input?
2. No, it's
0. That's how you know your y-intercept, because it's when x is 0, yeah? 2 times 0 is 0, 0 minus 1. That's where I get that from. That's why in a linear function, but it's why in any function, the plus or minus bit at the end gives you the y-intercept, yeah? So this line is actually an infinite number of points. So for instance, I can have whatever I like. What will a half come out as? So 2 times a half is 1. 1 minus 1 is 0. I could put 3/7 in to get another point. What would that end up being? Well, 2 times 3/7 is
6/7.
6/7, and then I've got to -1, so I'm left with minus 1/7. Yeah? So input, output, and that will be a point somewhere that makes up the line. So you've got to think of these lines, whether it's a straight line, whether it's a curve, whether they are an infinite number of points. Now what I would like you to do for me by next time, nothing amazing, nothing hard. I just want you, please, to read through that coordinate geometry bit. It's all about gradients and parallel lines having the same grade. It may well be absolute pointless to do, right? Because you already know it all, but I just want you to try and find out anywhere where you think we would like to talk about that. Okay. 692. You were close.
Vamos a aprender bien.
Yeah. So page 692, read the coordinate geometry and let me know what you need to go through.